It's small. It's simple. Just a white ball with dimples. But don't be fooled. This tiny sphere has conquered centuries of history, hidden layers of science, and some of the most advanced engineering on Earth. It has traveled from leather pouches stuffed with feathers to high-tech laboratories powered by robots and computers. And though it fits in the palm of your hand, it holds the power to change the outcome of every game it touches. This is the untold story of the golf ball. Imagine standing on a golf course in the 14th century. The land is rough, the clubs are crude, and the game is still in its infancy. The earliest golf balls are carved from solid wood, usually beech or boxwood. Heavy, inconsistent, and unpredictable, they were more blunt instruments than precision tools. Yet for the players of the time, they were a marvel, a symbol of leisure, a challenge to control, and the very start of a sporting tradition that would one day spread across the world. But wooden balls had limits. They cracked, they flew unpredictably, and they didn't travel far. The search for something better led to one of the strangest chapters in the history of sport. By the 1600s, golfers were using what became known as the feathery. Artisans would take a small leather pouch, fill it with boiled goose feathers, then stitch it shut. As the leather cooled, it shrank. As the feathers dried, they expanded. The result was a hard, compact ball. Each one took hours to make, often costing what today would be the equivalent of $20 or more. They were works of art, fragile and expensive, but for 2 centuries they ruled the game. Then came a revolution. In 1848, the gutta percha ball was born, made from the dried sap of a tropical tree. These gutties could be molded with far less effort. They were tougher, cheaper, and they changed golf forever. It was during this time that an accidental discovery was made. Smooth balls didn't fly, as well as scuffed ones. A scratched, nicked, or cut ball seemed to travel farther and straighter. Golfers began to notice a pattern. Imperfection made performance better. What no one realized at the time was that these accidental marks were altering the aerodynamics, reducing drag and increasing lift. Centuries later, this simple observation would lead to the most distinctive feature of the modern golf ball, dimples. As the 20th century dawned, science entered the game. Rubber became the material of choice, wound tightly around cores to create balls that were more consistent, more resilient, and more powerful. The balata ball, with its soft outer cover, became the standard for professionals, offering incredible control even as it cut easily. Players shaped shots in ways that were impossible before, bending the ball through the air, stopping it on a dime on the green. But progress never stops. By the 1970s, engineers began to replace natural materials with synthetic ones. Multi-layer designs emerged. Covers made from urethane or ionomer replaced balata. Cores were engineered for compression and rebound. The modern golf ball had arrived, a product not of handcrafting, but of chemistry, physics, and industrial precision. Look closely at a golf ball today. Around its surface are hundreds of tiny dimples, typically between 300 and 500 in number. Each one has been calculated to microscopic precision. Too shallow, and the ball won't carry. Too deep, and it won't cut through the wind. These dimples control airflow, tricking the air into clinging longer to the ball's surface, reducing drag, and creating lift. Without them, a golf ball would fly barely half the distance it does today. What looks like a simple pattern is actually the product of decades of aerodynamic research, wind tunnel testing, and computational modeling. But what lies beneath the surface is even more remarkable. At the heart of every golf ball is its core, the engine that powers its flight. Typically made from a synthetic rubber called polybutadiene, the core is designed to compress when struck, then explode outward with energy as it rebounds. Surrounding that core may be one or more mantle layers, each one engineered to fine-tune spin, distance, and feel. Finally, the outer cover seals it all together, built from urethane for softness and spin or ionomer for durability and distance. Every layer plays a role. Every material is chosen with intent. But how do all these pieces come together? The answer lies in factories that resemble laboratories as much as workshops. The journey begins with raw rubber. Delivered in slabs, it is mixed with zinc oxide, peroxides, and secret formulas of resins and additives. Giant industrial mixers knead the material until it becomes a hot, sticky compound. It is rolled flat, cut into strips, then chopped into small, uniform chunks. These chunks are then pressed into molds, heated to extreme temperatures, and subjected to tons of pressure. Minutes later, they emerge as perfectly round cores, glowing with heat and packed with potential energy. If the ball is a multi-layer design, those cores may be wrapped in additional layers. These mantles can be harder or softer, thicker or thinner, depending on what the manufacturer wants to achieve. A ball designed for professionals may have 3, 4, or even 5 layers, each one working in harmony to produce the precise blend of distance and control demanded by the modern game. Once the core and mantles are finished, it's time for the cover. Using a process called injection molding, molten urethane or ionomer is injected into a mold around the core. This is where the dimples are formed, pressed into the cover with absolute precision. Some factories use compression molding, pressing pre-formed halves around the core, but the principle is the same. Every ball must emerge perfectly round, perfectly balanced, and perfectly dimpled. The balls are then polished smooth, painted with multiple coats of bright white, and stamped with logos and markings. A final layer of protective coating gives them their signature glossy sheen. What started as sticky raw rubber has now become a gleaming, aerodynamic marvel, ready to be played at the highest levels of sport. The golf ball, it seems, is still evolving. Think for a moment about the journey. From feathers stuffed into leather pouches, to wound rubber threads, to the multi-layered marvels of today, the golf ball has never stopped changing. It is a mirror of human creativity, a symbol of the lengths we will go to improve, refine, and perfect even the smallest of objects. And while it may be small, its impact is massive. Without the golf ball, there is no drive soaring down the fairway. There is no chip landing softly beside the flag. There is no putt dropping into the hole to the roar of the crowd. The ball is the game. Every shot begins with it. Every story on the course depends on it. Next time you hold one in your hand, take a closer look. A simple object, a complex masterpiece, and a reminder that sometimes the most extraordinary stories come wrapped in the most ordinary packages.